look at modeling now with some inequalities. I think I used the word the other day, constraints. If you're looking at a real life situation and you're modeling it with inequalities, certain things, certain parameters have to be greater than something or less than something, and those are, you can think of those as constraints on a situation, right? So if you hear that word constraint, it just really means an inequality, less than, greater than, or equal to, that kind of thing. Okay. So let's look at our first exercise. John is mowing yards for his father's landscaping business. How much does he make mowing lawns for his old man?
$10.
$10 per hour. And where else does he work? Okay. How much does he make at the bakery? Somebody else? No way to know?
$10 per hour.
No. It's a mystery. Amy, how much does he make at the bakery? You don't wait. Amy, how much does he make at the bakery? What do you do? Huh? Read the words. Huh? No.
$15 per hour.
15.
I wasn't reading it right.
15. So you have to read. Okay. Okay. Hey, Amy, what's the most hours he can work during the summer? I'll wait here. You know all the most hours he can work during the summer? 52 hours. Right? How much does he need to make at a minimum? Amy? Okay, I just want to make sure that you understand you got to read these, right? $600 got to make covered, so he makes $10 mowing lawns, $15 an hour at the bakery, right? So he can work at so let's just underline these things, right? Landscaping, 10 per hour. Bakery, 15 per hour. He can work at most 52 hours per week. That's a constraint, wouldn't you say?
Yeah.
Okay. And he needs to make at least $600 per week. Is that another constraint on the situation?
Yeah.
It is, right? So part A, John works 14 hours mowing and 30 hours at the bakery. Does this satisfy all the problem's constraints? Well, how might you know? What are the constraints? If he works 14 hours and 30 hours, will he make, what's the one constraint? Is that going to be more than the 52, or it needs to be less than, right?
It's
And will he also make his $600 per week? Well, let's find out. Let's take this constraint.
times 10.
Let's do the hours one. 14 plus 30 gives you how many hours? 44 hours. Is that okay? That doesn't violate the 52-hour max, right? Well, how are we going to find out if it satisfies making at least 600 a week?
14 times 10.
14 hours there times $10 an hour plus.
15 times 30.
Well, let's keep the hours and stuff. So I just want to. So he's doing 30 hours, right?
Yeah, 30 times.
Just to stay the same. Times $15 an hour. So that's 140, right? Plus 450, isn't it? How much money is that?
Not enough. It's $590.
$590. So will it meet all the constraints?
No.
No, because 590 is less than 600, right? That make sense? So that's how the constraints work. So for part B, we could probably pretty easily write a system of, not equations, but wouldn't this be inequalities, right? Okay. So let's write in it. So they want what? X for the lawn mowing hours and Y.
Right, assistant of inequalities and discrepancies.
Thank you. And X for the mowing hours, Y for the bakery hours. So somebody give me an inequality for the total number of hours he can work.
X plus Y equals 52.
Hold on now. It says at most 52. Can he be less than 52 hours?
Oh, no, less than or equal to.
Less than or equal to 52, right? Okay.
Plus 600.
Now we need another inequality for the earning constraint.
X, Y,
X times Y is going to multiply his hours.
X times.
So wait, if he spends X number of hours mowing, how much does he make? If he spends X number of hours mowing, how much does he make? 10X, 10 times the number of hours, right? So 10X plus 15Y, right? $15 times the number of hours he works at the bakery. What is it now? He needs to. Okay, now you might see at least there and say, oh, at least less than. Is it? No, it's got to be greater than or equal to $600. Huh? So we understand how to set up that system? Okay. Let's go to part C. Looks like they're adding another constraint. He must work a minimum of 10 hours for his father. Is that the X or the Y?
It's the
Okay. Will he be able to make enough money to cover his living expenses? So let's say he does work 10 hours for his father. How many hours does that leave for the bakery?
it's 22.
So he can work a total of how many? 52?
Yeah.
So if we do 52 hours that he can possibly work, subtract 10 mowing lawns, 42 hours at the bakery. Does that make sense? So will he make enough money in this situation? How do we find out?
I'll do that.
Thank you.
42 times 15.
What about the lawn mowing?
10 times 10.
10 times 10, right? So 10 hours mowing lawns for $10 per hour, plus the bakery, which is what?
42.
42 times
15.
$15 an hour. So that's 100 plus what? What's 42 times 15? Anybody? Let's see here, calculator. 42 times 15?
600.
Oh, you beat me. Okay. 630. So that is $730. Will this work? So if he has to do a minimum of 10 hours with his dad, he can still make what he needs to earn. Okay? So yes. And over in part D, they want us to graph it. They want us to graph it. Well, it kind of looks like both of those. What method do you think you want to use? Use the intercepts method or put them in y equals mx plus b?
No.
Let's use the intercepts method. Let's take the x plus y less than or equal to 52. What's the x-intercept here? So x-intercept is 52, put a 0 for y, right? And what's the y-intercept? 0 for x, you left with y equals 52. Remember, I'm changing to equals here because I'm just finding some points. Right? Right, wouldn't it? Aren't those the intercepts?
Yeah.
Okay. Let's graph these in.
It would be all the way in, wouldn't it?
Well, I don't know. We'll have to put some numbers on there. Hang on a minute. Let's do the other one. So if we do 10x plus 15y greater than or equal to 600. If I want to find the x-intercept, what do I put in for y? That goes away. What is left? 10x equals 600. What does x equal? Well, hold on. What's x equal?
60.
60. There's my x-intercept for this one. Now let's find the y-intercept. Put a 0 in for x. What remains? Everybody say it. What? Everybody.
Y.
That's it? Equals 600. Okay. Divide both sides by 15. What's the y-intercept here? Oh, brother. Okay. So 600 divided by 15. 40. Okay. So it looks like maybe we should go out to 60 on the x and y axis. Will that work? Count by tens. It'd be accurate enough. I mean, if you want to be more accurate, you count by fives or even ones, right? But let's make sure we spread it out pretty good so we don't. So we'll call this like 10, 20, 30, 40, 50, 60. And do the same up here. 10, 20, 30, 40, 50, 60. Okay. Well, let's do the intercepts of 52. We'll kind of have to estimate there, right? Does everybody have a straight edge? Well, you should go get one if you don't have one. That's about 52, yeah? That's about 52. It might work. I think. And let's get.
Mine are really like.
No, that's fine. Which way are we going to shade this line, guys?
Less.
So, wait a minute.
Down.
How do you know it's going to be below it?
Because it's less than.
No, hold on.
Equal to.
Hold on, not even the equal to. How do you know it's going to be below? Not just because you see a less than sign, because why?
It's a positive.
Positive y is less than stuff, right? So I mean, but let's hold off on the shading first. And by the way, it has to be a solid line for both of these, right? Okay, so let's put the intercepts for the other one on there. It's just 60 for the x, right?
Yeah.
So here in the x-axis, a dot, yep. Dot there at 60. And the other one is at 40. And let's connect them up. Like that.
Right, we shade.
Now which way, hold on. So our first line's getting shaded below. This line's going to get shaded which way? Why? How come? Because you have positive y greater than stuff, right? So basically, well, this line's getting shaded above. It would be, oops. So the first line would be shaded all the way down below it, right? The second line would be shaded above, but where's the overlap going to end up? Right in here, right? So like right in this little region there. Let's put an S in there probably. Okay? Make sense? And let's label our lines here. What's this line here? This one with the 40 and 60. 10x plus 15y what? Equals, right? We're going to use the equal here because it's a line. And the other one is what? Equals 52. Okay. Looks like we've got an intersection point down here somewhere, right? It's going to be hard to say from the, because we like kind of half-handed our graph here, right? So it'd be really hard to solve this graphically, given that we just hand place these. But in part F, well, let's see, part E. John's father needs him to work a lot at the landscaping business, okay? So the point on the graph corresponds to the greatest number of hours he can work for his father. So what axis is for the landscaping business? The x-axis. So how far, knowing that this is our solution, our feasible region, right? How far along the x-axis can we go to maximize his time working for his father? How far out? 50? But if we go up from 50, does anything fall in the shaded region? Remember, when you put something on the x-axis and go up to the y, it's got to fall in the shaded region to work, right? So 30, well, that'll definitely be in there, right? Can we go further than 30 hours? Yes, but anyway, can you tell it's like right there where they intersect? That would be the maximum number of hours he could work for his father and still meet all the constraints. Because that's the farthest point on here that satisfies that shaded region. Does that make sense? Okay. So we can't really accurately get it from the graph, right? Unless we, if we had a graph with some regular grid lines already in there, we probably could, right? But let's do it algebraically here in part F. Find the greatest number of hours he can work for his father. So in other words, we're going to find this intersection point, right? Of those two equations now, yeah? So now we're going to treat them as equations and not inequalities. So let's write them down. It'd be x plus y equals 52, right? And then 10x 15y equals 600. Well, what should I do? If I add them up, will you do the variables all the way? No, what do you want to do then? Multiply the top one by what? You want to get the x terms to go away when you add them? I do negative 10, okay. So negative 10 times the whole thing up here. And by the way, guys, your work should be looking like what I do here, okay? That's what I expected. When you guys start learning this algebraic language more proficiently, then you can go off and kind of start doing your own style. But for right now, it should look like what I do. All right, so what's that give us then? Negative 10x minus 10y equals negative what? 520? Yeah. Yes. Well, it's a big whatever. And then bring the other one over, 10x plus 15y equals 600. Now let's add them up. These guys go away, right? What's that leave us with here?
45.
Is that right? Negative 10y plus 15y. It's negative 10 plus 15.
Negative 5. Negative
Positive 5, thank you. Amy?
I don't know.
You ever seen a number line? Here's 0, yeah? Read 0 on the number line. Here's negative 10 down here. I'm going to add 15, which means I move this way. Past the 0, 5 more, right? Okay. So positive 5y is going to equal what? Are we sure? Okay. 80. So we divide by 5. What do we get?
8. No.
No.
You're going to give it a
Well, think of it this way. What's 80 divided by 10? 8. But now we're only dividing it by 5, so 16. Right? Is that the answer to the question? What does y represent, guys? Hours at the bakery. What did the question want? Oh, so what do we need to do now? Solve it for x, right? So, yeah, I would say the top one, right? So we have x plus 16 equals 52. Subtract 16 from both sides, you should get 36 hours. Now, can anybody think of a way we could have gotten that a lot sooner? Back when we started the problem. They wanted to know about x. What was it that we did when we started? We made the x term go away and solved for y, didn't we? What could we have done to save a little time? Nate, you should have gone the other way, right? I mean, we got there, but, you know, just think about that, right? If they wanted to know about the x, I'd say, let's make that y term go away, then I'm done when I get x, right? Okay, just something to think about. I mean, you wouldn't be wrong in a test or something if you did it the long way. You'd just be here longer, that's all. Okay, let's go to the other page. What they want us to do here, I bet there's some systems of inequality, I have to guess. Brings to the following, write a system, models, problem. We don't need to solve it, it says. Does it say that? Anybody read that? Any readers in here say?
We do not need to solve it.
Okay, because those are words, right? We generally present other humans with words to convey particular information. All right. Why don't you guys read the first one on your own? While I stand here. Okay, so we should have 3 inequalities here. We're going to let R be the number of roses, right? And was it D for daisies, number of daisies? He wants what? At least 1 rose. So what is the inequality for at least 1 rose? R.
Plus G.
Huh? Is what? Less than what? Greater than or equal to 1, right? Right? Because less than 1 would violate the constraint, wouldn't it? So it's got to be greater than or equal to 1. Is there another inequality in here? Somebody else. At least 2 more daisies than roses. So how do we write that? So daisies have to be at least, so what? For at least. Greater than or equal to 2 more than the roses.
So 2R.
R plus 2. What's 2 more? Yeah. R plus 2. 2R is multiplying, guys. It's just 2 more. It's just like throwing another 2 in there, right? Yeah. Okay. How much do roses cost?
$4 each.
And daisies cost?
$2
How much must he spend?
$4.
Or less. Okay. What would be that inequality then?
R plus 2D is what's greater than 40.
Woo, look at you. 4R plus 2D. It's got to be less than, right? Less than or equal to $40. So 3 inequality. 3 constraints, right?
I still don't get these signs.
What do you mean? What about it?
We don't, like, I thought the other one was, like, yeah.
Backwards.
Yeah,
That?
I was
You mean-
expecting you to write, like, make it, like, the wide part open to the left. This one. The left.
Well, the wide part, wherever the wide part is telling you that that side's bigger. And where the narrow part is, that side is smaller or less than stuff. Then what's the what? The line underneath? Is that what you guys?
Alright, maybe Amy give up.
No. Look. What's this one here? D is greater than, right? Because the bigger side of it is towards the D, so D is greater than that stuff. Or you could think it's not narrow here, right? So this stuff is less than D. Yeah? Okay. Whatever part is bigger, you put the bigger part of the sign towards it. Well, you bet, so that's something you're gonna wanna fix, right? Stop yourself and think about it until it becomes natural, right?
And then the line thing is like give me all my stuff because I got 4 signs, not just 2.
It's a line. Just means equal. Anyway. Why don't you all read B and see if you can identify all the constraints in there and write a system for B. Everyone do that now on your own. Read this.
Yeah.
What are they attempting to create?
A giant food company is attempting to create a 9-carb brownie composed extremely
Entirely.
and protein. The brownie must weigh at least 10
Okay,
grams.
hold on. So maybe that's something, it must weigh at least 10 grams. Okay, but now, if we say it weighs at least 10 grams, its weight must be what? Greater than or less than 10 grams? If it has to be at least 10 grams, you have to say the weight must be what? These two. Greater than or less than? Forget the sign. Greater than or less than for at least?
Greater
These two!
than. Well, it's taking forever.
I know, but that's right. It's got to be greater than 10 grams, greater than or equal to, right?
Yeah.
Let's write that inequality, ladies. What would it be? Well, they want us to use X and Y, right? No, X is not the weight. All right, yeah. Well, it's the weight. X is the weight of the protein.
Okay, so why?
Yeah, and Y is the weight of the fat.
Greater than or equal to 10.
The weight altogether is the fat and the protein together, isn't it?
So X plus Y.
So X plus Y, if it has to be at least 10 grams, it needs to be greater than or equal to 10. Yeah?
Okay.
Okay. No. Ladies, everyone else, let's close our face holes for a moment, and these two are going to take over the class. So, let's look at this next inequality. What does this say?
No more than 100 calories.
No more, it can have no more than 100 calories. How many calories does fat have? 9. And how many does protein have?
4 calories.
4, right? Per gram. So how much does the fat weigh? How much does, let's say, how much does the protein weigh?
X.
And how much does the fat weigh?
Y.
Okay. So if fat has 9 calories per gram, and you have, well, let me go to protein. I'm sorry, I just got backwards. If protein has 4 calories per gram, and you have X grams of protein, how do you represent that? What?
He said 4X.
4X, yep. Okay, so we need all the calories together. Let's do the fat calories. So what do we add to 4X, ladies? 9Y. And this together added up can be no more than 100. So how do we write that? No more than 100. Everyone else zip it. No more than. So it can't, what? Okay, less than
So I'll leave your sign that way.
or equal to 100. And there you go. You guys just wrote a system of inequalities. Okay? All right. So let's move on to the next one. I'm going to let you guys read it because it seems like if I do the reading for you, don't. Okay, which one of you said I think I got it?
Me.
Okay, so, Freddie, what do you think you got?
So X stands for children. So X
Yep.
is 5X plus 10Y.
Okay, well, we needed an equality. We can start with that one. 5X plus 10Y. What about that? Is that the cost of the tickets,
Yeah.
right? Or the money they earn from it?
It's the cost.
And so what about that? What about the total Well,
Sell at least 2,000.
okay, so what is that gonna, what do we write then? For at least
Equal
2,000?
or- The elevator sign has to.
Just tell me, just use the words, greater than or less than.
That thing is greater than 2,000.
Well, could be equal to, right?
I'm sure. Why not?
I'm gonna write the other one off to the right instead of going above and below each other. Because I wanna, because you're gonna want us to graph it, and I wanna find the intercepts underneath it, if that's okay. So what would be the other inequality here?
X plus Y.
Okay, the number of tickets.
It's greater than or equal to 500.
No, it's less.
What do they
They
put?
only have-
Yeah, so you can't sell more than 500 or people be standing, right?
Oh, I didn't even think. But it's equal to.
So less than or equal to 500 seats, okay? Why what?
Nothing.
These are the number of tickets sold, right? What are the two types?
Adult and.
Children and adult tickets all together, because they only have 500 seats in the arena. The number that they sell is going to be less than or equal to whatever it is, okay? So in part D, they want us to graph this. So let's find the intercepts over here. Everybody right now on your own, find the x-intercept and the y-intercept for our 5x plus 10y equals 2,000. Why are they? Don't talk, just find it. Well, how do you find the x-intercept? What do you put in for y to find the x-intercept? What do you put in for y to find the x-intercept?
0.
We've done this a million times. You gotta start listening. So to find where it crosses the x-axis, that's where y is 0. So put a 0 in for y. What's 10 times 0?
0.
And so what's left then if that's 0? 5x.
Plus 5.
No, it's 0 you told me.
Yeah, but there's no big one.
Oh, we represent nothing in math with 0. It's not there.
Okay. 5x.
5x.
0.
Well, don't even bother writing it. 5x. Listen, if that term goes away, what's left? 5x equals 2,000.
Yes.
So write that down.
Oh. We can't buy a record.
What's the x-intercept then? Divide both sides by 5.
400 and last.
Hold on. Serenity, how do I find the y-intercept? What do I put in for x?
0.
And what's left?
10y equals 2,000.
Okay. Amy, what's the y-intercept? Divide both sides by 10. It's 2,000 divided by 10. Sit down. Girls, divide by 10.
200.
200, yes.
I got that.
Okay. So, yeah, I think you can count by hundreds on the graph. Be fine, out to like 5 probably. We should go out to 500. Well, let's get them both. What's the x-intercept for this one? X equals 500. That's easy, right? This one's pretty easy. Again, if you wanted to put it in y equals mx plus b form, you could do that as well. All right. So I'm going to go out to 500 on each one. So 1, 2, 3, 4, 500, 200, 300, 100, and 500. Probably the same here. 1, 2, 3, 4, 5. Label it.
How can you like make these lines so perfect? Because like mine don't even.
What's perfect about what?
Yes, and it's not even that. It's like I start out and.
You mean the distance between them?
Yeah, but like I can't even make it to the end. Like it's like.
You try this. You got this ruler here, right? One side, it might, maybe centimeters or something. I don't know. Maybe just go there. We need like 5. If you go 7 centimeters altogether, right?
Yeah.
So 5 is put you there, so maybe just do a 70 or 3 points. Something like that, there's ways around it. How about that? Let's find out what's going on. Are these going to be solid or dotted lines, by the way? Okay, so this one did an X at 400, or Y 400 and Y at 200, right? Get our thingy here. So that's that one, and the other one's 500 and 500. Okay. Now, so for our 5x plus 10y greater than 2,000, which way does that get shaded, above or below? How do you know? Positive y is greater than stuff, right? So that's this one. Which one is that? Oh, yeah. It gets shaded above, right? Wait, did I do that right? Oh, I switched it around. I put the wrong ones in there. Whoopsie daisy. You see what I did?
No.
So the y is 200 and the x is 400. I just got them. Did I get the other one? Yeah, of course, the other one's got to be like that.
Yeah.
So this one gets shaded which way, above or below?
Below, because it's smaller.
Because you see a positive y greater than stuff, it gets shaded above. What about the other one? Positive y less. So where does the overlap? Huh? It's in between here. That's not a triangle, actually. I don't even know if it's not even a parallelogram. There's nothing parallel in it, right?
At all. What's it called?
Quadrilateral? Now you do. That's why you're here, right? So this would be our solution set, right? And by the way, this is also known as what? Feasible region. Why do we call it that? Because that's a collection of points that does what? This collection of points that we shaded, what does it do? Yeah, it satisfies all the constraints, right? Remember, these are constraints, and everything in this shaded region is feasible because it doesn't violate any of the constraints that we have. Yeah? Okay. This is a different word. All right. So let's think about this one here. Children's tickets. What's the maximum number of children's tickets they could sell and still satisfy this?
5.
5 tickets? What's the maximum number of children's tickets that satisfies the feasible region? 100? 500, right? What's the minimum number of children's tickets that satisfy this? About 400. Right? So those are the ones that are on the edges there? Okay. Well, let's go to part C. You're excused. So my cough. No. That's slow. Anyway,
Not like this one?
so if the students want to sell exactly 500 tickets and make exactly $2,000, are we dealing with an inequality now? What are we dealing with? It says exactly.
I don't know.
Are we dealing with less thans or greater thans? No, what are we dealing with?
People.
Equals, okay? So if they want to sell exactly 500 tickets to make $2,000, well, we need to set up our system of equations now. So we'll take these two things, right? X plus Y equals, what was it, 500, right? And the other one? 5x 10y 2,000, okay. 10y equals 2,000. how many of each ticket should they sell? I'm going to give you guys a chance to solve this on your own. If you add the two equations up as they are, will one of the variables go away? No, so we'll make that happen. And you know how it's supposed to look, right? The way I do it here. Okay? I'm going to do that now. Should be recording. So we get 5y equals what? Negative 500. So y equals negative 100. What did y stand for? Tickets. I'm not even going any further to find x, because the question was, is this realistic? Or why is it not? Because negative ticket sales make no sense, right? So negative ticket sales make no sense. All right, and by the way, that's also why whenever we're doing a real life problem, you notice that our graph is almost always in this quadrant 1 where everything's what? Positive, right? Like you don't have, I'll just do this. You don't have the whole graph, right? Because in a real life situation, this exception to that, everything's up here in the first quadrant where it's all positive. And so if you get a negative answer down here, it just doesn't make sense, especially in this. Okay? And there's only one tiny little harmless Regis question here. Let's go take a look at that. Read that over on your own. You underline some key things to help you. Do so. And I would recommend, like, after you read it, instead of trying to work through the choices there, it'd be a whole lot easier after you read it. Just go ahead and write the system you think it is, and then find the one that matches what you wrote. Okay? So try it that way. This one says too? What do you guys?
You know it's my birthday?
Happy birthday.
Thanks.
We can model that. That's
I got
inequality.
you.
Keegan is greater than or equal to 12. Something like that. So a couple of you guys are saying it's number 2. Well, let's look at the problem. She has $50, yeah? That looks like a maximum, yes? So something has got to be less than or equal to 50 that she's paying for, right? Okay. And we've got ride tickets, and how much do they cost?
$1.29.
And then we have game tickets, and what do they cost? And is there a constraint here? Minimum of 10 rides and? Okay, let's do the minimum of 10 rides. Well, no, let's do the cost part first. So, if ours is the number of rides, what would the cost inequality be?
1.25
Plus 2G. She's only got, so that's the total cost altogether. Okay. Give me an inequality for doing a minimum of 10 rides. What can you say about R? Greater than or equal to 10. And give me one for at least 12 games. So G.
Greater than or equal to 12.
Oh, forgot the equal to. Okay? So choice 2. All right. I wonder if you want to grab your calculators, go back and try, why don't you try this one back on exercise 2? Why don't you guys see if you can graph this on your calculator with the inequality? So go up and grab where the calculator, go up and grab the calculator. Yes. By the way, you remember your default window goes from X of like -10 to 10 and Y from like -7 to 7?
What am I doing? First one?
Yeah. We're doing exercise 3, the graph part of it. So you're going to have to change your window. Like how wide the X part of the window is and how high the Y is.
I'm not being tricked.
I don't even know what you just said. I heard judge.
I'm judging that window. I'm not like a construction worker or somebody.
The viewing window. In your calculator.
Officer Benji looked in the window.
Windows everywhere, aren't there?
That's not
Just the window door.
All right, go ahead. Everyone do this now. Put it in your calculator. I would say start with changing your window. So guys, when you go to change your window, what's the minimum X you're going to put in?
Wait, what are we?
No.
Amy, figure it out.
What's the minimum X? No. Well, 0. Right? And what's your maximum X? Yeah. You know what though? I'd probably go maybe out to 600. So like your graph doesn't like hit the edge of the screen and what's your minimum Y minimum going to be? Somebody else? 0 and the maximum?
What would the X minimum be? Like -2?
What's this number here? Yeah, well, you might go, I mean, like again, so it doesn't hit the edge of the screen, maybe you start at like -50, I don't know. I like to do that. I mean, 0 to 500 for X, right? Or 0 to 500 here, and I might go like -50 to 600, just so I make sure.
Wait, what's my negative supposed to be?
That's not supposed to be anything.
So what about
I was giving you what I normally do.
Wait, what do we write in the
Control equals. Oh, you need to have it as a relation, that's why. Right, because this is not, right, that function is like y equals. So delete all that. And like when you're at that screen, you can just delete the equal sign, it gives you choice, or you can do menu, edit entry.
Drop.
So, so I think I'll go menu, Windows and 4, Windows settings. I think, yeah, 0 to 500 for X, but I wanted just a little bit of like margin, so I might say -50, something like that, and the 600 there probably, or 550, whatever.
Where do I get the greater than or less? Yeah.
Control equals. Control equals. And you guys have to be in the relation entry mode, right? That we've done a number of times. -50 to, whoops,
I didn't get the relation.
600. Well, do you see, does it look like this up here? Do you have that? Hit your tab button. Oh, so you're in relation, yeah. Control equals.
How do you get that?
Yes.
Ah, alright.
How do you get the in between like the shaded portion?
Did you use less than or greater than signs? Okay. I'm going to just click in there. I'm going to backspace. Lot relation 6. And I'll put in my.
What's the relation? What's the relation?
It's the way they state. Look. Graph edit entry 3. Like by default, it's in function mode.
I did it.
So it's like fx or y equals something, but if your equation's not in y equals form, like these are not, you'd agree, right? So I can either delete the equal sign or I can do this, menu, graph entry edit 3, pick relation 2. Now I can type it in as it is on the page, right? Remember doing that? So one of them is x plus y plus y. Where do I get my, what was it, less than or equal to sign? Control equals, and
Over, down.
we're down over 500. I was pushed by down arrow, I can put the other one in there. 5x plus 10y, and it was greater than or equal to, so control equals, thank you, 2,000.
Yeah,
So the overlap is kind of a different color there.
mine
So,
are different.
huh?
All of mine are different.
Yeah, but like, one of them here was, like blue, right? And the other one was orange, and when you overlap them, you get yeah, I know, I gotta think about that too. Your screen looks funny.
It's because I only did 100.
How did you do 100?
Uh,
Thing starts at 0. Why don't you change it from like -50 to +550 at least for both of them? Go from -50 to +550 at least. See, like if I started at 0, this would be right up at the edge of the screen.
Oh,
and I
yeah,
kinda
that's what mine is.
yeah, I kind of like to have a little margin. Right? Okay. So that's how you can graph them. And then like, like on the state test, right? If you need to find, geez, let me find where it crosses the x-axis, right? I'm going to go to menu. 5 maybe. Graph trace. Let's go down and see if it hits the. No, look at that. Down here. You see the coordinates as it's going? So I want to get a y of 0. See the y is going down? If I get to a y of 0, I know I have my intercept. Hey, there it is. And it says a 0. That's a 0 of the graph, right? So that's that intercept. Let's find it on the other one. Oh, we better move. We need a y of 0. Oops. Come on. There it is. Got it? All right.